Your brain has no folder labeled memories, yet it never loses your childhood home. There is no hard drive, no chip, no single spot where your first kiss or your best birthday is sitting neatly stored. So where does it all go? In the 1950s, a patient known as HM had surgery to stop his seizures. Doctors removed a small seahorse-shaped structure deep in his brain called the hippocampus. After that, he could still remember his childhood perfectly, but he could not form a single new memory. Meet someone twice and forget them minutes later, forever. His case proved something huge: memory is not one thing. It is built in pieces, in different places, by different rules. Here is how it actually works. When something happens to you, your senses fire off electrical signals. Neurons, the brain's nerve cells, pass this information to each other across tiny gaps called synapses. Every single experience you have triggers a unique pattern of neurons firing together. The hippocampus acts like a temporary stitching station. It binds sights, sounds, smells, and emotions from one moment into a single trace. But that trace is fragile. For the first few hours, it can vanish completely if it is not reinforced. This is why you forget a stranger's name seconds after hearing it. During sleep, something remarkable happens. Your brain replays the day's events, but faster, compressing hours into seconds. This replay strengthens the connections between neurons in a process called consolidation. Slowly, piece by piece, the memory is copied out of the hippocampus and moved into the cortex, the wrinkled outer layer of your brain, for long-term storage. This is why losing sleep after learning something makes you forget it faster. Physically, memory becomes real through synaptic strengthening. Neurons that fire together repeatedly grow more sensitive to each other, forming stronger and faster connections. Neuroscientists call this long-term potentiation. Essentially, your brain is rewiring its own wiring, growing new physical pathways every time you learn something. This is why a memory you revisit often becomes more vivid, while one you never think about fades and weakens. But here is the unsettling part. Every time you recall a memory, your brain does not play back a perfect recording. It rebuilds the memory from scratch, using the same neurons, and in that rebuilding, it can quietly change. This is why eyewitnesses can confidently describe events that never happened exactly that way. Your memories are not videotapes. They are constantly being rewritten every time you press play. So the vivid moment you are most sure about? It might not be the moment that actually happened. What memory are you certain about that might not be entirely true? Tell us in the comments.